And hello to you, Avon High School ACE College Algebra 2 students, or any students that might be watching from here and abroad and everywhere and so forth and so on. We're going to talk about our idea of the slant asymptote one last time with this video. Hopefully you have tuned in and you saw my example 2 that pretty much introduced the slant asymptote. We are in section 12.4 of a curriculum that we use here at Avon High School, College Algebra 2. And our example 3, just like I said, asks that we consider a few different functions here to determine whether or not a slant asymptote exists. And if one were to exist, we're going to go about finding it. So like I said, if this video doesn't make a lot of sense, it's probably likely that you need to see the example 2 video first. So let's go ahead and take a look here. It says, for each of the following functions, determine if there is a slant asymptote and give a reason. And if one does exist, let's find its equation. So if we look at example 3a, first thing that we're going to look at is the degree of the numerator, which in this case is a 3, and then compare that with the degree of the denominator, which is 1. And as soon as you see that the degree on top is not 1 larger than the degree on bottom, we're going to know that we do not have a slant asymptote. So that's the simple answer to A. No slant asymptote. Now it did ask for us to provide a reason. So we're going to say because, I'm going to abbreviate because, and we're going to say that the degree of the top is not 1 larger than the degree of the bottom. It's in fact 2 larger. And that's all you'd have to do. Nothing more to it. I'm going to go ahead and allow us to use the informal words top and bottom instead of numerator and denominators. They're a little bit easier to write. Okay, excuse me. So we're going to move on to B. Now in B, we have the degree of the top being 1 larger than the degree of the bottom, so we do have a slant asymptote. I'm not going to give a reason for this answer because it's going to be fairly the same every time that we encounter the situation. So I'm going to go ahead and go and go about finding that slant asymptote. So if you watched the last video, you learned that you can use synthetic division. So you can just simply write down the coefficients of each of these values that you see, and then you can put those inside the box. And then you would take the denominator, which in this case, x plus 4 is equal to 0, and you're going to solve that, and that's going to provide you with the number that goes outside the box. Now, if you recall, the process of synthetic division requires that you just bring the first number straight down, multiply numbers outside of the box, add numbers that are inside of the box, and really by the time you get to this stage, you're finished. It doesn't really matter what you get in this last position, that is the remainder position. It does not play a role in finding the slant asymptote. And then we look and we notice that the first value is acting as our A, the second value is going to act as our B, and we're sort of operating under the rules that y equal ax plus b would be the equation of that asymptote. So you're ready to write the equation. Y is equal to 1/2 x plus 3. Now, in example 2, we had a wonderful luxury of being able to see the graph of the function g of x, or whatever function we were dealing with, and we could reinforce our answer, or check our answer. Now, we don't have that luxury here, but if you guys have access to a graphing calculator, whether it's your TI-84, your Inspire, you could even go on and use Desmos. But I'm going to go ahead and use the Inspire here, and I'm going to sketch. I'm going to pull this up here, and I'm going to sketch that function. Let's give myself a blank graphing template here, and we're going to type in the coefficient. Let's do that again. We're going to type in the coefficient 1/2. So we have 1/2 x squared, and then we're going to add 5x, and then subtract 4. And we're going to place all that over x plus 4. And then when we sketch that, we see this. Now, it may not be real clear that the slant asymptote is working for us because this graph is so spread out. So we could do a lot of things, one of which we could go in and we could change the window size, the default 10 in all 4 directions. Maybe that needs to be sort of zoomed out a little bit. If you don't want to do that, you can zoom out by going into Menu, Window Zoom, and choose the Zoom Out feature. And I could just put the center here probably about where the origin is. Maybe go out a few times. That kind of narrows things down a little bit. But what I like to tell students to do is to actually sketch that asymptote and see if it looks like it's legitimate. So you want to escape to get out of the zoom mode. So I just hit the escape button. And then if you remember the equation, y equal 1/2 x plus 3, let's go back into this and let's sketch into the F2 y equal 1/2 x plus 3 and take a look at it. So as we kind of peek at this red line, we kind of look and see, does the blue curve seem to kind of gradually get closer and closer to the blue line? And I think we can certainly say that for a fairly decent distance here, but I know it gets a little muddled here. But you can do some interesting things like zoom in and kind of isolate in on what's happening over here. Maybe I'm kind of curious in this region. So I can zoom in a few times, and you will see that separation begin to exist. I'm going to escape to get out of the zoom mode. And then, because I'm using this software, I can actually grab the screen and I can kind of slide it over. You're going to have to pay attention to this value here to see that if anything's actually happening. But if I do this enough, we could just stay here all day, and I could do this forever and ever. You would enjoy that, right, as the viewer. But I think you would see eventually that this blue curve is going to get closer and closer to that red tangent line, or that red asymptote. It's going to take a while for that to really be visible, but in time it's going to happen. So if I go back to zoom standard, I'm going to rest assured that I've found the equation of that slant asymptote. Now, I'm not going to do that for each of these examples because that's something that certainly you guys could do to verify on your own. We're just going to work the algebra to find out what the equation is. So we're going to go to example C now, and we see something that's just a little bit different. In this particular problem, you have a numerator that's been factored and is not written in this normal standard descending order. So that must be fixed. So the very first thing that we're going to do is we're going to expand out that numerator. And as I expand it out, I'm also going to write in descending order. So I can see that these inside terms are going to produce my highest degree term, negative 2x squared. If I work the x terms, I would be dealing with negative 4x. And then I would also be dealing with positive 3x. When those are combined, I would get negative 1x. And then it's pretty clear to see that your constant term is the two outside numbers in this case, which is a plus 6. So I'm pretty confident that I've got those pairs of binomials expanded correctly. And so now for the denominator, I'm just going to rewrite what I've got. So when I start to set up the synthetic division, I know that my coefficients are going to be negative 2, negative 1, and positive 6. And if there's ever any discrepancy or indecision about exactly what value you put out in front, the whole thing can be remedied by taking that denominator and setting it equal to 0. So if you're going to add 1 over and then divide by negative 1, you're going to get x to be negative 1. So that's the value that's going to go out in front. So if we drop down this negative 2, and then we do our multiplication, and we do our addition, we do our multiplication and our addition, we find that we have got a remainder value here that we're not going to worry so much about because it doesn't play a role in our synthetic division, or it plays a role in our synthetic division, but it doesn't play a role in determining the slant asymptote. But we're going to then rely on the fact that this guy is our A, and this guy is our B, and then we're going to write the equation, I might do this in blue, we're going to write the equation y is equal to negative 2x plus 1. And rest assured, this will be the equation of the slant asymptote. And you can certainly check this on a calculator. Okay, let's finish this up with part D. We have a similar situation where the degree of the numerator is 1 higher than the degree of the denominator, so that means all systems are go for a slant asymptote. We're going to take the 2x plus 4, and we're going to set that equal to 0, and we're going to get x equal to negative 2. But we're also going to keep in mind that a 2 would have been factored out of that denominator, and that would serve as our greatest common factor in this particular case. So we're going to write down our coefficients, 1, -5, -6. We're going to do our upside down division box, and we're going to put -2 out in front, and we're going to go to town with our synthetic division. So the 1 drops, we're going to multiply, we're going to add, we're going to multiply, we're going to add. Once again, the remainder has no bearing on the equation of your slant asymptote. Now, this one's a little tricky. Remember, if we had a common factor in our denominator, we are obligated to take the result that we got and divide by that value. So our A turns out to be 1 over 2, and our B turns out to be -7 over 2. So that's going to force our equation to be y = 1/2 x minus 7/2. Now, because we have a very unusual y-intercept, well, we do have a very unusual y-intercept, but I would say overall this is a very unusual equation of a line. Let's go ahead and take a look at D graphically and make sure that we've done the right thing. So I'm going to go back to the TI Inspire, and I don't need any of this anymore, so I'm going to hit Doc B. Since I'm in a scratch pad, I can get rid of all that, and then I'm going to go back to the graphing calculator scratch pad. So I'm going to put my fraction template in there, and I'm going to sketch the numerator, or type in the numerator, x squared minus 5x minus 6, and then I'm going to place the denominator in as 2x plus 4, and there's our sketch. Again, you probably don't see the different branches of this like you normally would, but if you just look barely down here, I think you can start to see the beginning of that particular branch. So not a big deal if I want to zoom out just a little bit. Maybe position this at the center, or maybe somewhere in between. Maybe that's a better idea. Maybe somewhere right around here. It really doesn't matter. That just becomes now the new center of your screen. I think that gives us a pretty good view. So I'm going to get out of the zoom mode, and let's go ahead and type in the equation of that slant asymptote. Y = 1/2 x minus 7/2. So in a fresh entry line, y = positive 1/2 x minus 7/2 or 3.5. It really doesn't make any difference. They're the same, and that's what we've got. Once again, I asked, take a look. Do we see that asymptotical behavior? And I would say just even within this viewing window, we've done a pretty good job of illustrating that red diagonal line serves as an asymptote. It's a barrier that the curve will get closer and closer to, but will never touch. So I think we've done a good job with that one. Let's close out this video, and we'll talk about this very short example 4, which is the last example in your section 12.4 notes, where again we have the equation of a rational function, and it is also pictured to the right. Our job is to find the equation of the slant asymptote and to draw it in. So it's kind of like doing what we've been doing with some technology, except obviously not using the technology. The graph of the function is already provided, and we're going to hand draw in the asymptote. So let's go ahead and jump to it. We're going to take those coefficients. First of all, we realize this does indeed have a slant asymptote, as the degree of the numerator is 1 larger than the denominator. So here are the coefficients, a trio of -2's. Now out in front, we're going to take the 3x plus 6, and we're going to set that equal to 0. And when we do so, we subtract 6, divide by 3. Wouldn't you know? We have another -2. So we continue and drop down the first -2. We're going to multiply numbers on the outside. We're going to add numbers on the inside. Multiply on the outside, add numbers on the inside. There's our remainder. Once again, he's the guy that we're not going to use, but we have to recall that if you have a situation where there is a common factor in the denominator, a constant that factors out, you would bring him out, and that 3 has to divide into each of these results. So you would have -2/3 as the A value and +2/3 as the B value. So that would force your equation to be y = -2/3 x plus 2/3. Now, that's going to make things pretty interesting when it comes time to graph this. Even though the grid blocks here are fairly decent size, I would recommend that you use a fairly sharp pencil when you're sketching this. Now, what I'm going to do is I'm going to use a line drawing tool, and I'm going to make sure that I have a fairly thin, very thin, in fact, um, line. And I'm going to change its color so it shows up. Let's use something like, let's use a red so it shows up. So what I'm going to do is, first of all, note that the y-intercept, as you can see right here, the y-intercept is 2/3. Now, that's not a very pleasant position, but it's one that we're going to deal with nonetheless. So that's right about here, let's say. And then from there, the slope looks like it goes down 2 blocks, and it goes over 3 blocks. Now, the best way to do that is to say go down 2 blocks. Well, there's down 1, there's down 2 blocks. And over 1, 2, 3 is going to send it right about into that vicinity. So that's pretty much the direction that that's going to take that way. And then I can grab the other side of this, and then I can just extend it. And all I got to do is I got to be really careful, and I got to make sure that that y-intercept needs to stay right around the 2/3 value. And I think I've done a fairly good job. If I can redirect your attention back right here, I would say that I did a good job of keeping that at the 2/3. And then the slope does look like it does go down 1, 2, over 1, 2, 3 for the most part. Again, it's kind of tough to do. It's a very challenging line to graph. Up 2, left 1, 2, 3, I'd say that we retain that slope. Let's do one more. Up 1, 2, over left 1, 2, 3. Pretty good job, but I don't know if I could have pulled that off so easily had I not had a very thin drawing tool. But if you step back from this, it certainly looks as if that equation or that line serves as that slant asymptote. So honestly, you've pretty much seen every kind of thing that can happen. The most challenging things that are going to come your way are certainly going to be these problems that have the factor in the denominator that sometimes students forget. Anyhow, this wraps up not only this video over the slant asymptote, but it wraps up all of the videos over section 12.4. My students, you can begin work on your 12.4 practice worksheet, and we will pick up where we left off, and we'll start talking about section 12.5. Anyhow, thanks very much, and I'll see you next time.